Hello guys, it's me again. In the previous video, we already did a revision on what racemic mixture is. And in this video, we will look at mechanisms that can help us to produce racemic mixture, okay? So as I mentioned, mechanisms that produce racemic mixture, or it has another name called racemate. Okay, you can see these two terms in the textbook or in some past papers. The first one is Sn1. The second one is nucleophilic addition reaction. If you remember, for Sn1 is halogenoalkane, right? And for addition, nucleophilic addition reaction is carbonyl compound. Okay? Carbonyl compounds. Okay, we will look at the Sn1 of halogenoalkane first. Let me give you a structure. Okay, now if you look at this halogenoalkane, which degree of this halogenoalkane belongs to? So since this carbon is bonded with 3 bulky alkyl groups, so obviously this is a tertiary halogenoalkane, right? When you draw mechanism, remember to add the partial charge. So as what we learned, halogenoalkane can undergo Sn1 and Sn2 with nucleophiles, right? For this one, do you still remember which one it goes for, Sn1 or Sn2? Give you 2 seconds. Okay, time passed. So the answer is Sn1 because it is a tertiary halogenoalkane which can lead to the formation of tertiary carbocation. So the tertiary carbocation is very stable. Do you remember? Because it has alkyl groups surrounding it, pushing the electrons to the positive carbon, stabilizing the positive charge, right? And at the same time, the alkyl group surrounding the positive carbon will create a steric hindrance, preventing the nucleophile from attacking the positive carbon directly. So the first step will be the breakdown of this bond. So it will form a tertiary carbocation, and it is an intermediate which corresponds to the minimal point in the energy profile. Okay, do you remember what I taught? These 3 alkyl groups, they are electron pushing in nature. They push the electrons, okay? Alkyl groups, electron pushing in nature, okay, stabilizes the positive carbon, okay, carbon. Now what I want to say is, when you look at this one, I'm trying to explain why a racemic mixture will be produced. Because in the second step of the mechanism, this nucleophile, this carbocation, since it's planar, okay? Planar means you can put it on a piece of paper and the bond angle with each other is 120 degree, planar, right? So imagine the right now, the nucleophile here, it can attack the positive carbon from the front, right? Or from the back, okay? Now imagine you have a piece of paper putting vertical, okay? It's like this carbocation on the paper, and the nucleophile can attack it from the front or from the back, okay? And this will produce a pair of enantiomers and its mirror image, and it has equal chance to happen, right? 50 chance for the nucleophile to attack the carbon from the front, and 50 chance to attack the nucleophile from the back. So it will produce the carbon, the product. And its mirror image with equal amount, okay? So this will be a racemic mixture. That is what I told you in the previous video. That's why the mixture produced from this reaction will not rotate the plane of polarized light, not because of the products are not optically active, but it contains a pair of enantiomers and its mirror image in equal amount. So the ability of rotating the plane of polarized light cancel out. And the reason for this happen is it involves a planar carbocation. Planar carbocation, okay? So which will lead to the attack of the nucleophile from the front and from the back, or you can say equal chance to attack on the positive carbon from each side, the front and the back, okay? I already told you, imagine you have a piece of paper, putting it vertical, so the OH minus can attack from the front of the paper or from the back of it. And these two processes have equal chance to happen. This will produce a pair of enantiomer and its mirror image existing in equal amount. So that's why they cancel out. Okay? Okay, next video, we will look at how nucleophilic addition can produce racemic mixtures similarly. Okay? Remember, the key point is there is a carbocation, okay? Planar, equal chance to attack on each side, producing a pair of enantiomers with equal amount. This is called racemic mixture. Do you remember the keywords? Okay, goodbye class.